You know, when you hear Shinkansen, what's the first thing that pops into your head? Speed, right? The famous bullet train. But here's the thing. It's so much more than just a fast train. It's actually a whole philosophy of transportation. An idea that, even 60 years later, is still the one everyone else is trying to copy. So yeah, let's get into it and figure out what makes this system just so special.
And that really is the big question we're tackling here. I mean, think about it. We live in a world where tech gets outdated in, what, a year? So how on earth is a train system designed back in the 50s still the undisputed king of the hill? And the answer? Well, it's not just about the hardware. It comes down to some really radical thinking that put one thing above everything else.
And that one thing is safety. Absolute, non-negotiable safety. Just look at this number. 0. Let that sink in. For 60 years, 60, carrying billions of people through some of the worst earthquakes and typhoons you can imagine, there have been 0 passenger deaths from a crash or a derailment. That's not just a good track record, it's practically a miracle. And it all started with a crisis.
All right, so to really get the Shinkansen, you gotta rewind the clock. We're talking post-war Japan. The country's economy is booming, it's this huge miracle, but there's a massive problem brewing. A giant bottleneck that was threatening to bring the whole recovery to a screeching halt. And that problem was the Tokaido line. This was the main railway artery, the lifeblood connecting Tokyo and Osaka. Now get this, it made up just 3% of all the track in the country, but it was carrying almost a quarter of all passengers. It was totally, completely maxed out. We're talking goods not moving, people stuck. The whole economy was in danger of just seizing up.
So this crisis kicks off this huge debate. On one side, you had the realists who said, hey, let's just add more tracks to the line we already have. Simple. But on the other side, you had the dreamers, guys like Shinji Sogo and the chief engineer Hideo Shima. They had a much wilder idea. They basically said, forget the old network. High speed is impossible on that thing. We need to build something brand new from the ground up.
And the core of their big idea was this huge technical gamble. See, Japan's old trains ran on a narrow-gauge track. It's cheaper, sure, but it gets really unstable when you try to go fast. Shima was adamant. They had to use the wider international standard gauge. Now, this was a massive decision. It meant the new Shinkansen couldn't use any of the old tracks. They were choosing pure speed and stability over being compatible with the rest of the network.
And that decision to build a totally separate, walled-off system became the bedrock of the Shinkansen's whole safety philosophy. It wasn't about making a train that could survive a crash. It was about building a system where a crash could literally never, ever happen.
So let's put that in perspective. In most of the world, high-speed rail is built on this idea of crashworthiness. The thinking is, hey, our trains might have to share tracks with slow freight trains, and they'll cross roads, so a collision could happen. The solution? Build the train like an absolute tank to protect people when the inevitable occurs. Japan's approach, totally different. It's called crash avoidance. And the goal here is to make a collision impossible from the get-go. The entire system, the tracks, the signals, the train, it's all designed together as one big integrated machine whose whole purpose is to make an accident physically impossible.
So how do you do that? How do you make a crash impossible? Well, they built it on 3 fundamental pillars. First, physical isolation. There are no roads crossing the tracks. None. Second, exclusive use. Only Shinkansen trains are allowed on Shinkansen tracks. No slow-moving freight trains to worry about. And third, and this is the big one, automatic train control. Look, at 300 kilometers an hour, a human driver can't react fast enough. So the computer is in control, handling the speed and all the braking automatically.
Another one of these radical ideas was how they powered the train. Most trains have a big, heavy locomotive at the front pulling everything. The Shinkansen, though, uses what's called an electric multiple unit system. Basically, they put smaller motors on pretty much every axle of the train. This spreads the weight out, which is way better for the tracks, and it means you can accelerate and brake much faster. Plus, it's super redundant. If one motor gives out, who cares? The others just keep on humming.
This whole system approach also led to some just beautiful and elegant engineering solutions, and a lot of them came from looking at the world around us. So, as the trains got faster and faster, the engineers ran into this really weird problem. Japan is super mountainous, which means tons of tunnels. And when the train blasted into a tunnel at high speed, it was basically acting like a giant piston, compressing all the air in front of it. The result? A massive sonic boom when it exited, loud enough to rattle windows and upset the locals.
Not good.
The fix for this came from an engineer who also happened to be a bird watcher, a guy named Iji Nakatsu. He realized the kingfisher bird solves this exact same problem every day. It dives from the air into water, two totally different densities with almost zero splash. So he thought, what if we redesign the nose of the train to be shaped like a kingfisher's beak?
And would you believe it, the results were incredible. The new Kingfisher nose cone didn't just solve the tunnel boom problem. This beautiful nature-inspired design also slashed air resistance by 30% and cut electricity use by 15%. So the train could go faster, using less energy while being quieter. It's a total win-win-win.
And that same kind of smart thinking goes into surviving earthquakes, which, in Japan, is a very real concern. It's a multi-layered defense. You've got the physical stuff, like steel-reinforced bridges so they don't collapse. But the real genius is the early warning system. It detects the very first harmless tremors of an earthquake, the P waves, and automatically slams on the brakes seconds before the really destructive waves arrive. This system has proven itself over and over again.
Okay, so the hardware is amazing, but the true secret sauce of the Shinkansen isn't just the metal and wires. It's what the Japanese call humanware, this unbelievable culture of discipline, precision, and dedication that makes the whole thing run like a Swiss watch.
I want you to really look at this number, 24 seconds. That is the average delay for the entire year on the busiest Shinkansen line. And get this, that number includes delays from things like earthquakes and typhoons. In Japan, a 1-minute delay is considered late. 24 seconds? I mean, that's a level of punctuality that's just, it's hard to even comprehend anywhere else in the world.
And you can see this precision in action with what they call the 7-minute miracle. When a train arrives at Tokyo Station, it only has about 12 minutes at the platform before it turns around. In that tiny window, a cleaning crew swoops in, cleans and wipes down all 1,300 seats, turns them all around to face the new direction of travel, and gets off in just 7 minutes. It's like a perfectly choreographed dance, and it's what lets these trains run as frequently as a subway.
So, when you put this radical technology together with that intense human discipline, you don't just get a great train. You get something that literally reshaped a country. And that economic legacy, well, it's got a bright side and a pretty significant shadow side.
The Shinkansen was absolutely the engine of Japan's post-war economic miracle. It created this massive Pacific Belt megalopolis and made same-day business trips between huge cities a normal thing. But there was a dark side. Politicians pushed to expand the network into areas that just weren't profitable, saddling the national railway with just mind-boggling debt. This debt-fueled spending helped create a massive economic bubble that eventually popped, leading to Japan's infamous lost decades of stagnation. And now, Japan is getting ready for its next great leap, the Chuo Shinkansen, which is a maglev train. And the jump in technology here is just huge. We're talking about a train that literally levitates 10 centimeters off the track, hitting speeds over 500 kilometers per hour. It's going to slash the trip from Tokyo to Osaka down to just 67 minutes.
So all of this brings us back to that first question. When you look at the whole picture, from its radical safety philosophy to its massive economic impact and its next-gen evolution, what is the real, true legacy of the Shinkansen?
In the end, it's just not a train, it's a total system. And it's still the gold standard today because its creators understood a fundamental truth. Speed is totally meaningless without safety. Punctuality isn't an accident, it's the result of a million tiny details all executed perfectly. The Shinkansen's greatest innovation wasn't just metal, it was a philosophy to treat time, space, and safety not as separate things to balance, but as one single, integrated, and absolutely non-negotiable whole.